Now, this is one of those things that I think we all know eventually we're going to come across a database that has corruption in it, but how you react and how you deal with that can make a real big difference to where it goes from there. And hopefully everyone will take away from this some ideas and things that you can do to deal with that database corruption, especially if it's not something you deal with every day. So here's a little bit about me. I blog regularly at my website, stevestedman.com. I'm the founder of the Database Corruption Challenge, like I mentioned. Cover what that is in a minute. And I work on about one actual corrupt database per week lately, it seems like, and figure out how to get the data back without losing anything. I've got a book that was published called Common Table Expressions. It shows people how to use that. I got a program I built called Database Health Monitor, which is given away for free, that lets you go and learn a lot of stuff about your SQL Server. And I've been using SQL Server for just around 25 years. And basically I'm a freelance database consultant, and I work on this type of stuff all the time. So the Database Corruption Challenge, what this is, it's something I started about 8 or 9 weeks ago, and it's an about weekly event where I'll go build a corrupt database and confirm that it can be recovered, and then I'll post that and give people the opportunity to go and solve it. And then that runs for about 3 or 4 days, and people who participate send me their solutions. They send me the results, and I take a look at it. I usually run through all of them on a local database and confirm that they work, and then the winners get posted each week, and prizes will be awarded at the end of the 10-week contest. I've got some t-shirts that are being made up that are going to go out to the winners, and after the 10 weeks are up, I'm going to start another challenge at that point. So we just finished week 7 in the challenge, so don't think if you're coming in late that feel free to jump in and participate, but know that there's another challenge coming after that 10 weeks. And to participate, you just need to sign up for the newsletter at my website, and you'll get informed as to what's happening with current database corruption challenges. So what we're going to cover today is detecting corruption, figuring out exactly whether you have a corrupt database or not, tracking the corruption, figuring out what's gone bad, figuring out what you can do to determine what actually is bad, things beyond just using DBCC CheckDB. And then things to do before you try and fix or remove corruption. I mean, one of the worst things that can happen is you run across corruption and you immediately go in and run DBCC CheckDB with the option to fix the corruption, and you might lose a fair amount of data with no way to get it back. So we're going to look at some things you can do to prevent that, things to do before you actually attempt to remove it. Then we'll take a look at different ways to remove the corruption, and I'll go through 3 example corrupt databases that will go about fixing them and recovering all of the data out of those and not losing anything as we correct that corruption. So first, we'll take a look at some ways to detect the corruption. Probably the most common one that people use is DBCC CheckDB. When you run this command, it scans your entire database and checks the integrity of tables, indexes, just the entire structure of the database, the file formats, the file groups, everything to make sure that it's all in line with what SQL Server is expecting. But occasionally when that's running, it comes across something that's not quite right. Now, you'll get something displayed on screen with a bunch of red error messages like this. And anytime you get anything red displayed out of CheckDB, you know it's something that's a problem that you have to look into. Now, another option is you can run DBCC CheckTable, and that can be run against an individual table rather than the entire database. So if your DBCC CheckDB takes too long to run regularly, you can run CheckTable and run that against a subset of your tables on a regular basis. This does the same thing that CheckDB does, but it just does it on a smaller scale where it's looking at a single table at a time. And then there's a bunch of other options with DBCC Check, where you have check constraints, check catalog, check alloc, check file group, check ident. They go through, and each of these does a subset of what the entire CheckDB command would do. And you can get similar output from those. And then there's another option to find out if you may have encountered corruption somewhere along the way, is the MSDB suspect pages table. If you just select star from that and take a look at what's in there, there are certain cases where if corruption is encountered, for instance on a backup or a restore, things like that, it will get logged into this table. Now, if you look at this table and you realize, and there's nothing there, that's not completely indicative that there is no corruption. It's just if there is something showing up there, it is a clue that you may need to look further and figure out where that corruption is. Another way you come across corruption, and this is often reported by users, is just by running a query. In this example, select star from revenue, return the following output here. Logical consistency-based I/O error, and a number of things that are pointed out there on that. And we'll look at these in specific detail in just a moment, but sometimes you're not even trying to look for corruption and it pops up when you're trying to run a query. Sometimes that corruption will prevent you from seeing any results that are returned from that query. Other times you may get bad results back, or in some of the data in the result set will be incorrect. So let's take a look at tracking the corruption now that we've found some ways that we can go find it. And we'll go through and try this in just a moment. But one way to track it is when you know you've got corruption, or just when you're doing regular maintenance, you want to check on things, check the error log. You may have things, error messages showing up like this when you run a query, or dbcc check db, or you may have events showing up in the error log. So here's an example of something showing up in the error log. And this one, in fact, is pointing out here that page 1:9 in the database is corrupt. And that's one that there's examples of that on my website of how that one can be dealt with, but that's the actual boot page of the database. And that will, if that page is corrupt, that will prevent your database from loading. And it'll actually leave the database in the recovery mode. But once you know you've got some corruption, you want to take a look at everything you can to get as much information as you can before trying to do anything. So you'll be able to find out whatever you can from the error log, but also you want to take a look at what you can query. So here's an example of a table that's corrupt. You select star from revenue, you get 54 rows back. Well, okay, in that case, maybe you didn't get any errors, but you need to look and figure out, well, is 54 rows what was expected? And there's some things that we can go through, and I'll show that in just a moment, to figure out, is that 54 rows, or however many rows that are being returned, is that the right number of rows for the results that you're looking at? Then another thing you can do with that is to check your non-clustered indexes. Now, keeping in mind that a non-clustered index is just a copy of some of the columns out of the table, you can use that copy, or that non-clustered index, as a way to go and compare what's in the index to what's in the table itself, whether it's a heap or a clustered index or a clustered table, to go and find out, well, maybe what's different between the two of these. And the way you can pull directly from a non-clustered index is to use the with index hint, as shown on the bottom of the screen here, and you give it the name of that index. And as long as all of the columns that are shown or that are selected in the query, as long as all of those columns are in the index or they're referenced from the clustered index, you can pull all those results back. And in this example we're looking at here, you can see that department ID and revenue are in the clustered index, but the clustered index also includes the ID, which is, or the non-clustered index also includes the ID, which is in the clustered index. So let's take a look at some things that you want to do before fixing or removing the corruption. The first thing you usually think is, well, how can we fix this quickly before anything gets worse? But you want to look at some other things first. Like, do you have a way to start over if something goes wrong? It's really tough when you start working on database corruption and you go through and you try something and it turns out that what you tried made things worse and you have no way to undo that. Now, sometimes that means that you're doing your work inside of a transaction and you can roll that transaction back. Other times it means that you create a backup of the database, even in its corrupt state, create a backup of the database first so that you can bring back the current state if you need to. And there you go, do you have a backup of the current state? And the other thing you want to think about with that is, what other backups do you have available? Do you have a backup of last 24 hours or an hour ago or at some point before the corruption occurred, so that you can go through and maybe compare what's in one backup to what's in another? The other thing that's really important here that's oftentimes overlooked is, if your solution is going to cause data loss, what can you do to save anything before causing that data loss? So for instance, if you do certain options on dbcc check db that we'll take a look at in a minute, or check table, it will go through and find those corrupt pages, and if there's any corruption in that page in memory, it'll just throw out the whole page, which means you might lose several rows in that page. So you take a look at what can we save off before that whole page is dumped out of memory. And then the other thing I like to look at is, do you have someone to review your ideas with before proceeding? And sometimes, I mean, this can just be explaining what you're going to do to a coworker, and I find that just explaining what you're going to do oftentimes can point out maybe a flaw or something in the plan, but you can, with that other person the other person you're presenting that to, they can take a look and throw out other ideas, or maybe give you ask questions that will make you think of something that you didn't think of. Dealing with corruption, people are oftentimes a little bit flustered because it's not something you deal with every day. So just explaining what you're going to do can make a big difference in getting it right. And then think about this question. What if you go through the whole process but determine that part of your cleanup dropped a row that could have been saved in the beginning? How are you going to go back and get that again? Now, it might be that the backups that we talked about earlier would save that, or it might be that you just need to go through the process twice and go back and get it. But having that way to repeat it will allow you to get as much of the data back as possible if you make a mistake somewhere along the way. So then, once you have determined there's corruption, once you've got a good plan to how you can get back if there is a problem, how do you go about removing it? Well, if the corruption is in a non-clustered index, that's probably one of the easier ones to deal with. You can just drop and recreate the index, and the corruption goes away. You have no data loss. The index gets rebuilt out of all the data in the original table, and everything's good. One option is to restore from backup, and I know I've talked to people where they've said, I don't really deal with corruption. I just restore from backup. I go back to my last good backup and then replay transaction logs forward. Sometimes that's the best solution, but depending on your frequency of backups or when the corruption was encountered, restoring from backup may not be your best option. But if you are going to restore from backup, you also want to consider the tail of the log backup, meaning backup to the current point in time so that you can replay to a certain point if you need to. Another option to get rid of corruption is if it's a smaller table, or if there's a way to get all the contents back, meaning like you've saved everything out of the table, you can truncate the table, and truncating the table will get rid of the corruption, whereas if you try and just delete everything out of a table with the delete statement, oftentimes that will fail if there's corruption in the table. So truncate's a quick way to clean it up if you've got a way to get everything back. And then you've got the DBCC check commands, and this check table or check database are very similar here, but on check table you give it a table name and with the repair rebuild option, and that goes through and attempts to rebuild it. Oftentimes that's not going to do anything, and it's just going to tell you that you need to try the repair allow data loss option. Now, the repair allow data loss option, that's the one that you want to stop before running that one and make sure that whatever is going to be lost, you've got a way to get it back if you can. And the way that check table or check DB using the repair allow data loss works is it just scans through until it finds a corrupt page or a page in memory that it determines that it's not right for some reason, it's corrupt in some way, and it just deletes that and cleans it up. Any rows or index data or whatever happened to be in that page is then lost at that point. That's okay to do if you've got a way to bring the data back somehow. And then check DB versus check table with repair allow data loss. This one always worries me a little bit, because if you're doing check table and you're cleaning up one table, you know that at most that one table is what's going to be lost or destroyed with you if you're using repair allow data loss. But if you do check DB on the entire database, it might be that it checks and it fixes the first things that it told you about when you ran CheckDB previously, but then there were some other things after those are fixed that it detects are corrupt as well, and it might end up doing more than you're expecting it to do at that point. So we'll take a look at the first example here, but before we do that, I just want to open it up and see if there's any questions.
There was just one question about the session being recorded, and yes, the session will be recorded, but other than that, Steve, we're good to go.
Okay, great. On to example 1 then. So this is an example that came from the actual database corruption challenge. This was the week 1 example. And If anyone wants to work along with this, you can go to my website and download the sample zip file that has all the samples from this presentation right now and try it on your own. But in this example, you're given a BAK file with a corrupt database. That's it. That's all you have access to. And the original database was already destroyed by a network admin attempting to solve the problem. So somebody who didn't know enough about SQL Server jumped in and somehow destroyed the actual running database. But you were fortunate enough that they made a backup of that corrupt database. However, the problem is when they made that backup, all earlier non-corrupt backups were overwritten with the corrupt backup, meaning they didn't have a very good backup retention policy there. They only had one BAK file, and when the latest was backed up, it overwrote it. So when this database gets loaded and you run checkdb, you see the following on screen. And rather than going through the detail here, I just want to jump into the demo and I'll show the actual code. But before we do that, you want to think about what would you do first, and just as we go through this, be thinking about these things. If whatever we try makes it worse, how can I undo that? And what can I do to determine what is corrupt? And what can I do to recover the missing data caused by the corruption? So let's jump into that demo now. So the first one of, well, what if I try this and it makes something worse? Well, we have a BAK file, and as long as we don't destroy that original backup file, it's a full backup, we can always come back to it and use it. So in this example, I'm going to just start by taking a look at what version of SQL Server we're using, just because we've got a lot of different things that may happen with different versions of SQL Server. Let's see here. There we go. So the first error was there because I dropped the database from earlier, but we're running SQL Server 2014 version 12.0.4100.1. Sometimes you get a little bit different results, so I always like to make sure what version of SQL Server I'm using before going through this. So we've got the backup file that's been provided, and I've just placed it on my C drive in a directory called DB Backups, and it's called corruptionchallenge1_2008.bak. Now, this is a 2008 version that will get upgraded as we run through it, but it could be any version of SQL Server at this point. So what I'm going to do first is take a look at, and I'm using the file list only on the BAK file to look at, well, what are the files that were backed up? And when we look at it, you can see that the files were in sort of this default SQL Server 2008 install location. However, I'm going to be restoring them to my SQL Server 2014, and I need to put those in a different location. So the way I'm going to do that is I'm going to, on the restore database command, move each of the file groups shown here into a new location called C SQL data. And this is just a test server I'm working with here. If this was actually in production, it probably wouldn't be a C drive. But if there's any opportunity, I'd want to test this on a non-production server before actually doing it in production. So we'll do the restore, not a very big database. It comes back real quick and it upgrades it from 2008 to 2014. And we have 178 pages in that database. Okay, so we've now got the database at a point we can work on it, but we don't know exactly what's wrong with it. So we're going to connect to that database and run dbcc checkdb. And when we do this, I'm going to put some carriage returns in here so we can see the whole message. A few things are going to jump out at you here. First one we're going to take a look at is the object ID here. And we can do a select to go figure out what object that actually is, but we can cheat and just jump down here after all the red messages and see that the object is a table called revenue. Okay, so that's, we know it's one table there because it's the same object ID referenced through these three different errors. We look at the index. We can see the index ID is 1, as it's shown all the way through here. So that's the clustered index. So we know it's actually the table itself as a clustered index that has the corruption in it. And then we can also see a few things like the page that's corrupt right here is page 1:158, and that's referenced a couple times. So from what we're seeing here so far, it looks like there's only one page in the entire database that's corrupt. However, sometimes when you do this, you'll fix the corruption in one place and then run dbcc check db again and find out that the corruption is somewhere else. Okay, so what we know at this point is it's in the revenue table. That's the table itself, or the clustered index, that's corrupt, and it's page 1, file 1, page 158 that's corrupt. Okay, so let's take a look just to confirm. We can select from sys.objects with that object ID that was in that error message and confirm that yes, that is the revenue table. But we saw that from the output. It's good to check it. So let's just do check table on the revenue table. And what you'll see at this point is we get back all of the same messages that we saw when we did check DB. So two things could happen here. One, we're lucky and that revenue table is the only place in the database that there is corruption. Or two, the corruption is so bad it's preventing CheckDB from going further and checking any other tables. So let's take a look at what we can do to fix this. So the first thing I want to do is I want to put the database in single user mode. And what that's going to do, it's going to dump everyone else except for me out of the database, and it's going to make it so that nobody else can mess with the data while I'm working on it at this point. Now, given that we just restored this from a backup, there's probably nobody else using it, but if we were doing this in a production environment where there could be other people connecting, I just want to make sure nobody can be changing the data while I'm working on fixing it. So we put it in single user mode, we get command completed successfully, and we know at this point that this connection is the only one currently using that database. So let's take a look at what's in that corrupt page, which I think was shown as 158. So when we run, we're going to use dbcc trace on of 3604, which allows the output from dbcc page to be displayed. When we run it on corruption challenge 1 is the database name, file 1, page 158 with the output format of 2 here. And when we run that information, or when we run that statement, we can see the output we get here from dbcc page has a bunch of information in here, and as we page through it, we can see things like the type is 1, which means it's a data page. The header version is 1, which is, well, it should always be 1. And then things like the slot count. So that tells me that there's 27 rows from the slot count that are represented in that one page. And then as we page down, you can see that this is what's actually represented in memory on that page. And you can go through and actually, knowing the format, map out from each one of these rows, each one of the 27 rows here, you could extract the information from this output. But there's some easier ways to do it. So let's take a look at what we can do there. So we know we have page 158 is corrupt, and there are 27 rows in that page. And just a note here, as you're dealing with corruption, you want to put a lot of comments in your code as you're going through here so that once you do something to change the database and you forget, oh, how many rows, what were there on that page, you can come back and check on it in a little bit, because it might be that something you do changes that and you're not easily able to get to see what that result is again. Okay, so let's take a look at what the whole table looks like now. We know we have one corrupt page and that has 27 rows in it. When we run select star from revenue, just let's look at the whole table. It comes back and we get a total of 54 rows returned. And from just glancing at it, you may not know that anything's wrong at this point. Okay, so let's now take a look at how we can find out what might be wrong or what might be corrupt in that table. So I have a query here that I use to look up from sys indexes and index columns and columns to find out
Hey Steve, your audio just broke up. I don't know if you can hear me, Con, or if it's mine.
index, it has the ID, and that ID is actually included in the non-clustered indexes, even though it's not shown here, because that's used to jump from the non-clustered index back to the table to look up the data. But we have year, notes, department ID, and revenue. And however, if you look at the name of the indexes, and this is one of those things that happens in the real world quite often, is you get to a point where somebody named an index and then they changed it. So like this index was originally called department ID and year, but it actually has department ID and revenue in it. So you want to look and find out what is actually available in those indexes. So what this tells me is looking at the non-clustered indexes, all of the columns in the table are represented there, and I can go and actually pull data back from those non-clustered indexes and see what it would look like, or what's shown there, because that's a copy of the table, and to see if it's different than what's in the base table at all, or the original table. So let's take a look first at pulling some information from the non-clustered indexes. So here I'm just going to select ID, year, and notes from revenue, and the index was called NC for non-clustered, bad name for an index. And then there's a second select statement which is going to use the NC department ID and year, which was actually poorly named, but we're going to pull back the column, or yes, the columns that exist in that index. So if we run the two of those, well, let's just run them one at a time. The first one, if we run that, we can see we get back 54 rows and ID, year, and notes. And if we flip over and look at the execution plan, you can see that all that was done was an index scan, and it didn't actually go to a table scan in any way. It just ran through the non-clustered index, and everything you're seeing there was returned from that non-clustered index. And we get data back for all 54 rows. Okay, so now we'll do the same thing with that other index. You can see index scan. All the data returned came back from the index, and we're able to bring back 3 of the 5 rows from this one and 3 of the 5 rows from the first one, which gives us enough to then match it up and figure out what we can do to find out what may be missing. Now, in the week 1 of the corruption challenge, Brent Ozar participated, and he put these. He threw out this next set of queries here. It was kind of a quick and dirty check, he said, just cheating here, but there could be differences between the rows or null values, meaning that this is just summing up all of the values in the row. It could be that certain corruption would show that these are the same. So what we're going to look at is looking at the clustered index, or looking at the table itself and forcing that with this index hint. And then we're going to look at the same sums, looking at the non-clustered index. Run those, and we can see the results we get back. They total up to, for the sum of the department IDs is 108 on both of them, so those match. And the sum on the revenue adds up to a big number here that's exactly the same between both of those. So quick check, the revenue and the department ID columns are probably the same between both of those tables. There's some checks we'll do a little bit later to prove that. But now let's take a look at the year and the notes column using those same, or using the clustered index versus the other non-clustered index. And you can see that the years add up to the same number here. However, the sum of the length of the notes does not add up to the same number. So that tells me there's something wrong in the notes column at this point. So going through this, we haven't done anything to fix the corruption yet, but we have a better understanding of what's in, of what may be corrupt at that point. So at this point, we believe the corruption exists only in the notes column, but we'll do some things to confirm that. So what I'm going to do here is select from the revenue table from the clustered, or the non-clustered index, and outer join to the clustered index, and compare the notes column between what's in the clustered index versus the non-clustered index. And I can see at this point that row 31 in the non-clustered index has this text, and in the clustered index it's null. Therefore, that's a clue to where the corruption may be. Okay, so what if I could just take this value and copy it from the non-clustered index and do an update? So if I copy that, paste it in here instead of the word test, and I'm going to wrap it in a transaction just to be safe, and I'm going to begin transaction. I'm going to try and update the revenue table and just update the notes. And we get a message from SQL Server that says a severe error occurred. So I'm trying to update a specific row in the database that is corrupt, and it's not going to let me do it. So I'm just going to roll back what I just did here, and it had crashed out of the begin transaction anyway, so I didn't need to do that. Okay, so let's figure out another way to approach fixing that. So if we query the 2 non-clustered indexes as shown here, and we bring back all of the columns, we can run this query and it looks just like the original table because we've brought everything back from the indexes, but if we look at the plan, you can see that only the non-clustered indexes are being hit to bring that data back. Okay, so now I'm going to use the except command here and say, first I'm going to use that same select statement I just did and compare that against select star from revenue, and then I'm going to switch it around in the other direction and run that. And we can then see that comparing in both directions, there's only one row that's different between pulling the data back from the non-clustered indexes and the clustered indexes. And the only thing that's wrong is that notes, which we determined earlier. So, but I can't fix it without losing any data at this point, so I want to save the data. So here I'm going to create a table called revenue save. It's got all the same columns as the original table revenue did. The only difference is the ID is not an identity, and it's not clustered on that either at this point. So we'll create the table. What I'm going to do is run that same query that we ran earlier to pull everything back from the clustered or the non-clustered indexes and put it into this table called revenue save. I'm then going to select star from that. Okay, there's everything out of the table. We do have 54 rows back on this revenue save table. And then I've got another statement I'm going to just double check to find out what's different. And I can see here that it's showing the first half here is coming back from the revenue table. The second half is coming back from revenue save. And you can see that what's different is the notes column. Okay, so let's go about trying to fix it. So we're going to do this inside of a transaction so we can roll it back if we need to. Begin transaction. I'm going to then check table with repair rebuild. And what happens here is the repair level caused the repair to be bypassed. So what DBCC check table at this point is saying is based off of the options we've given it, it can't repair at this point. We've got to do something a little bit more, I guess, aggressive here, and that would be the repair allowed data loss is the minimum repair level for this. Okay, so let's just check the table, and we check it, and it still has 54 rows. If we look down at row 31, that's still there. That's still corrupt with the null in it. So let's just roll back what we did there, which really wasn't much because it said it couldn't do anything. And let's try it a little bit more aggressively here. We're going to begin transaction. We're going to check the table with repair allowed data loss. Okay, so we've got good news here. It says the error has been repaired, and a number of errors through the table have been repaired. And yeah, revenue table is good. However, it says there's only 27 rows, but there were 54 rows there before. So let's just look at what we've got there. Well, we've got rows 1 through 27, so that's page that was cleaned up with the repair allowed data loss lost half of the rows in the table. So we can take a look at what's missing, and we can see that, well, what's missing, comparing that against our save table, is rows 28 through 54. Okay, no problem. So I'm going to actually commit this instead of rolling it back, and I'm going to confirm that the corruption has been removed. Okay, corruption is removed, and run check DB, check the whole database. Okay, there's no corruption at this point in the database. We know there's not 54 rows there, but we can get those rows back. So what I'm going to do is set identity insert on revenue, meaning we're going to be able to insert to the table that has an identity value. We're going to insert everything out of revenue save that's not already in revenue. We get 27 rows there. We then turn identity insert off, and we select from revenue, and we have all 54 rows back. And if we scan through to, what was it, 31, we can see that 31 has the right value in here at this point and not the null. Check the differences again just to be sure there's no differences there between the indexes, or sorry, between the save table and the table itself. So I'm going to drop the save table. I'm then going to put the database back into multi-user mode so other people can use it. I'm going to check one more time to make sure that there's no corruption. Okay, we're good. And then the last thing I'm going to do is I'm going to back it up and make sure that, since we've got this recovered state, that we can get back to it at that point. So at this point, we have completely recovered all of the data in the table. Nothing has been lost. And I think we're good at this point. So I'm going to open it up to see if there's any questions at this point.
Yeah, just one question actually. Are there other things that to worry about if the database is a SharePoint content database?
If the database is a SharePoint
content databases. So basically content databases for a SharePoint site.
Yeah, you know, that's one I don't know off the top of my head. I can look into that, but what we're looking at here is getting the database exactly back to the point that it was before the corruption was occurred without losing any data. So sorry, I don't know the answer to that question.
Okay. There's actually just one more that just came in. What if there's no non-clustered indexes?
What if there's no non-clustered indexes? Okay, well, let me rephrase that. What if there's no non-clustered indexes, or there are some non-clustered indexes that don't have all the data you need? That's probably, so that's the perfect question to lead me into the next example. So let me just jump in, unless there's any other questions, let me just jump into example 2, and I can show you what happens if you don't have the right non-clustered indexes to bring the data back. All right, so example 2 is a little bit different. And I've already given you the hint that it doesn't have the right non-clustered indexes, so we're going to have to do this a different way. So example 2, the story, a backup was run yesterday. After that backup, several changes were made to the database, inserts, deletes, updates, and more. And sometime today, corruption was encountered when someone attempted to run the following query, select star from revenue. And you have 2 backups here, one from 2 days ago, and one is your latest backup. And there's no transaction logs in this one, unfortunately. And then when you do that select star from revenue, you get this error message saying that there's a logical consistency-based I/O error. And this is different than the previous example in a couple of ways. In this one, we don't have the right non-clustered indexes to get all the data back. And 2, we can't even pull the data back from the original table because when we select everything out of the table, we get errors showing up here. So let's just jump into that, and I'll show you how you can go about doing that. And depending on what's corrupt or what your backups are and all that, things can vary greatly on how you go about doing this. But let's just take a look here. So I'm going to just go and use the restore file list only to just check out both of these backup files, one being the latest backup and the one being the 2-day ago backup. And there we go. So we look at the files, and again, these are not in the directory I'm working with here. They came from another location. So I'm going to have to remap them with the move command on the restore database like this. So I'm going to restore the latest backup because that's the one with the corruption in it, and I want to see what's going on with that first. So I will restore it. Okay, it's been restored. Now we're going to take a look at, we'll use the database. We'll check DB. And again, the with no info messages, that makes it so it only will display errors. So we check the database, and we get errors at this point. So here we can see a little bit different errors, but we can see the object ID here references revenue. The index ID is 1, so that tells us it's in the clustered index rather than somewhere else. And it looks like the pages that are being referenced are 244, 244, and then 245 has a linkage problem linking back to 244, and 243 may have the same issue. Okay, so let's take a look at what's in page 244 then. We'll use the trace on command. And when we look at this, we scroll through here, and there's some things that jump out at me right away as maybe being a problem. The header version is 2. Well, there's no such thing as a header version of 2 in SQL Server. So that tells me there's something corrupt that's messing that up. But let's just look down here because if that's corrupt, there's probably something else going on corrupt there. So I'm going to take this first row here out of the header, copy that out, and see if I can figure out what's going on. So if I copy that, I've already pasted it here. And what it's looking at is that the header version should be 1, at least for all versions since SQL Server 6.5 or 7, I think. And the type should be 1 for a data page, and we know this is a data page from what the error we saw earlier, but it's showing up as zeros, which is wrong. and then a number of other things that are incorrect here throughout the headers. So how do we know these are incorrect? Well, you don't necessarily have to know everything that's normally in a header, but what you have to know, or what you can look at, is the neighboring headers from page 244. Let's look at 245 and 243. So if we look at 245, scroll down and copy off that first section out of the header, and then we'll do the same thing on 243, which I did earlier, and we can see that the headers shown here where they're not corrupt are very different than what's shown up here where they are corrupt. Now, what some people did in this challenge to fix it was they went in and they used DBCC write page, which I do not recommend doing, and they just corrected the header themselves and were able to get the database restored. I'm not suggesting you do that, but that people have done that. So, okay, so let's go on and attempt to figure out how to fix it through the normal methods here like we did before. So last time we took a look at what indexes we have available, and let's take a look this time to see what indexes we have available. Here we have one index, department ID and year, which again named badly because it actually contains the columns department ID and revenue. And because the table doesn't have a clustered index on it, it doesn't have the ID on it either. So there's not really enough information in this index to recover like we did in the previous example. So that's the question of, well, what do we do if we don't have the data in the index? Well, let's look at that now. So we can use the index, though, to at least figure out how many rows there are. So we're going to look at the just selecting everything out of the index, and we'll just go and run that, and we can see that the index contains 10,057 rows. Okay, and we know that the index is not corrupt based off of the error messages that we saw earlier, so we'll assume that 1057 is the correct number of rows. And again, I'm putting lots of comments in here so that if I have to scroll back and see what we had, it's easy to do that later. Okay, so then let's just take a look at what's in the revenue table. We run that, and we get this logical-based error that we saw earlier in the PowerPoint slide. And however, even though we've got the error showing up there, we can see we did get some data back. So if we page down here to the bottom, we can see that there are 595 rows returned, and that the ID represented in there so far is 601. Okay, so that gave us 595 rows up to ID of 601. So let's use that same select statement, but we'll throw an order by ID descending, meaning we're going to start at the bottom of the table and scroll backwards until we hit corruption and see what we get back. Okay, so if we go to the end, okay, same error message, but if we go to the end here, you can see it started at ID of 10,064 and came back all the way to ID of 615, and it returned 9,450 rows. Okay, so we got 595 and then 9,450, so let's do the math. We knew there were 10,057. We were able to get back 595 plus 9,450 just fine. So that leaves us 12 rows missing. Okay, not so bad. We can figure out how to get 12 rows back. That's easier than the 27 that we had in the previous example. So let's look at the index again and figure out what IDs are there between 602 and 614, because 615 and 601 were the boundaries of where the corruption was encountered. And we can see that we get back 12 rows here, IDs number 602, 603, and so on, and you can see that 610 is missing in here, and we get a total of 12 rows back. So what I did is I copied that, pasted the missing values in here, and comma separated them so that we can come back later and use those to look data up if we need to. But I'm also going to take another look at that page 244 that we looked at earlier, and that's the one with the bad header here, of course. But what's interesting is if we look at the slot count, there's 12 rows represented in that table. So the 12 rows that are missing match the 12 that we brought back up here. Okay, so I'm going to take this results that came from the DBCC page, save those off. I'm going to put them in this DB backups folder and save it as DBCC page 1. And I'm going to save that off because we're going to come back and take a look at it and compare it to what we have in the non-corrupt database. So now what we're going to do is restore the corruption challenge from 2 days ago and or the corrupt database from 2 days ago, and we're going to compare what's there. So I'll restore that database that was our old backup file that we were given and remap it to different files. I'm then going to look at what IDs we have in there in that missing range, and we can see that there are 13 of them showing up, and 610 is in here. And the interesting part, if we look at row, actually if we go back there, so 610 wasn't shown before. The missing row is 610, but if we convert 610 to hex, that's then shown as 262 in hex, but the way it's represented in memory as an integer with the little endian format is to reverse the order of it. So that's the way it looks in memory, and that's important. We'll come back to that in just a minute. So let's take a look at a couple of things. We'll first look and see what's in that revenue table. And we can see that there's a different number of rows than we had before, not the original 10,057. So we will check the missing rows, and we can see that the missing rows, all 12 of them are represented there. We could just fix the corruption and copy these out of the old backup, but we don't know for sure that they're the same. So what I'm going to do is, using this backup, I'm going to dump the output from DBCC page on the same page that's corrupt, save the result on that as DBCC page 2.report, and we'll take a look at that in a second. But if I scroll back up here to this number, which represents row 610, scroll through the results, I can find that there's the ID for it, and it's the only one that's showing that on this page. It's located at slot 8. It's the 8th row in that entire page. So what I want to do is figure out, I'm going to go back over here to the file system and take these 2 reports that we just saved and use WinMerge to look at the difference between them. And taking a look here, we can see that, well, the headers are different because that's corrupt, so we'll ignore that. So we're going to page down and see that for each row that's represented here shows up at a different address. Okay, that's fine. It's at a different address in memory, but everything else inside of the pages are the same. And page down, everything looks the same until we get to the row here, which happens to be row 610, which is missing, which we would expect, or it's in the one data file, but it's missing in the other one because it had been deleted. We can then page through the rest of them and see, yeah, it's all the same down to the end, and in the one DBCC page output couldn't display the offset table because of the bad page type. So we know everything is the same in that that 2-day-old backup except for that row 610. Okay, so let's fix it then. Let's use corruption challenge 2. Go back to the database, the original corrupt database. We're going to create a table to save, a temp table to save everything into while we work on it. I'm going to take the first 595 rows out of the actual revenue table, put them in there. We know those are good. I'm going to take the last 9,400 rows and 9,450 rows and put them in that save table. Okay, so now we've got everything except for what's in the corrupt page. So I'm going to go against the 2-day-old backup, grab the list of IDs we know that are exactly the same, and put those into the revenue save table. And then at that point, I'm going to go back to the original table called revenue, and I'm going to truncate it. I could have used DBCC check table, but I know that truncating it will clean up the corruption. Check DB. Okay, there's no corruption at this point. I confirm, I should have done this before, I guess, but I confirm what's in revenue save, and it's all 1057 rows. And then I'm just going to take everything from revenue and put it back into revenue save, and that throws an error message, so that's where we have to do the identity insert. Put all of that back. Look at revenue. We can get all the rows back, 1057. Check DB. Everything's good at this point. I can drop the revenue save table. I can put us back in. I'm going to delete the 2-day-old restore, and then I'm going to make a backup of the entire table. And at this point, we have everything back from the original, from prior to the corruption occurring. And because of the difference that we did between the 2 pages that we dumped out, we're able to see that everything is there and everything is good at this point. So that wraps up the second example. Are there any questions at this point?
Yes, just one question. What about if there are foreign constraints on the table?
Okay, and that's a great question. If there's foreign key constraints on the table, that would make it a little bit trickier. You could disable the foreign key constraints when you reinsert the data into the table, and you'd have to re-enable them. Or you could, instead of using truncate, you could go through and just use the DVCC check table as was shown, and it would just delete what was missing and then use something like the merge statement to bring everything back. But it's a little bit more work, but you can certainly do it at that point. And just make sure that if you do disable or drop any foreign key constraints, you have to put them back on later. Any other questions?
What if there's no backup to compare the pages as you did this in this example?
What if there's no backup to compare the pages at this in the example? That's a good question. So one of the things you do at that point, because in this specific example there were only 12 rows missing, you could have, with a little bit more work, dumped the data out of each one of those rows that was in that corrupt page using the dbcc page command, like what we saved off to disk, and then you could go through and manually determine which rows you wanted to bring back, or copy them off, copy them out and create insert statements. There's some really great examples, and I don't have time to go into that today, but on my blog there's some examples of people who wrote code, for instance, a common table expression that would rip through that DBCC page output and actually convert it back into insert statements to put that data back into the table. So more than one way to fix it in these examples, certainly. Any other questions?
No, I think we're good. Thank you.
Okay, so I had originally planned on doing 3 examples, and this next one, I guess I'm just asking at this point, it's probably take about 10 minutes to go through it. Should I skip the next one or run over a little bit on the timing here?
You could probably run over. David, are you okay with that?
Yeah, I'm good with that. It's recorded, so if people do need to drop off, they can pick up the last demo through the recording.
Okay, great. So this one's a little bit quicker than the others. So this was week 6 in the database corruption challenge. Corruption was encountered running dbcc checkdb, and it looked like this. There's the page number. It's in index ID 2, which is not the clustered index. It's a non-clustered index. And the story behind it is somebody had disabled the SQL Server agent, so there's no recent automated backups. So back to the example, somebody just asked a minute ago, what if there is no backups we can use there? Well, after the corruption was encountered, a backup was performed in order to distribute the corrupt database, and then there were no transaction log backups, only the single full database backup that contains the corruption. So on this, there's an old joke, either you need to have a good backup and recovery, or you need a good resume, pick one. Well, in this one, there's a third option. In this case, there are no backups, so all you have are your skills, and your skills to fix the database. This is your skills to fix the database, not your skills to write a resume, and these skills will look really strong one day when you do work on that resume. So let's take a look at how do we fix this example. I'm going to restore corruption challenge 6 here, which is the database we're using. Oh, the alter statement didn't work, but that's just because it didn't exist. So the database was restored. I'm going to then restore a second copy of the exact same database, but I'm going to rename it to underscore copy. And the reason I'm doing this is the first time I ran through this, I didn't have all the data I needed, so I had to have a copy of the data to go back after I cleaned something up. Okay, and then let's take a look at what's corrupt here. Okay, so that's the same error message as we saw in the PowerPoint slide in the index ID of 2. So let's see what index that is. So we'll just check table on customers and confirm it's the same thing. So, yep. So let's take a look. If we select star from customers, what we get back. Okay, we get back 254,000 rows. So then I'm going to see what are covered by indexes. Okay, we've got first name and last name covered by indexes, so not everything is covered. But what I'm going to do here now is look at the first name and last name and compare that in the clustered index to the non-clustered index. And then I'm going to compare it the other way using the except statement. And we can see that what's different, or what in these here, is that some of the names don't match up. In the first example, there's a name Alexander. Sorry, in the second one, the name is Alexander. In the first one, the name is Ali Wander, which I don't know if that's a valid name, but it could be. And in the second one, the name is Mia, and the first name, it is something that's not Mia. So that tells me that in the corruption, somehow these names have been messed up along the way. So what I'm going to first do, and I'm not going to run this one, but I tried the repair rebuild. It didn't do any good. But we'll go into single user mode. We'll then we'll go into repair allowed data loss like we did before, inside of a transaction, of course. This goes through, the errors have been repaired, and what that means is that the page was thrown out. However, the page was in an index, so the index was able to rebuild that. When we run checkDB at this point, we see there is no corruption. If we do the same comparison between the indexes earlier, we can see that there are no differences in any of the names that we could see there in the index. Okay, but I've got this copy that I made earlier, so let's compare what's in the non-clustered index in the current table to what's in the non-clustered index in the other backup. And we can see that although all the corruption has been repaired, we still have two names that aren't quite matching up for some reason between the two of those. Okay, so I'm good at this point. I'm not going to roll it back. I'm actually going to commit the transaction knowing that those are the names that don't match, and I have to still go fix those up somehow. Okay, so at this point, all the corruption is resolved, but we have data loss, and the goal here is to eliminate the data loss. This is the same query I just ran showing what was different there. So what I'm going to do now is look at the entire customers table between the other backup and the current table, or sorry, in the current database, and we see that, okay, the names are exactly the same, which means that there, in addition to the corruption we fixed, there's some corruption that was hidden in the names. So if we look at what's in the names, we can, in the first name specifically, we can see that there are these two bad ones showing up, and then more popular names being used here. Now, it is possible that these were real names, but with enough data, you can sort of trim it down and figure out, well, maybe those are wrong. So, or you could go talk to somebody in your support organization or somebody who knows who the customers are and look it up and determine that the first name was supposed to be Alexander and the first name on this one was supposed to be Mia. So we correct those, and then as part of the database corruption challenge, there was this checksum test to see if you had the right data, and at this point, the data has been fixed. We've manually fixed up a couple of items that were corrupt, but were not visible once the index got rebuilt on the with the DBCC check table, and everything is back to normal, and nothing is missing at this point. Any questions? I know that one went pretty quick, but any questions on that example?
Actually, I think we're good.
Okay. So what I've got is just to wrap up the rest of the presentation here. Next is example 4 is on your own. This was week 3 in the database corruption challenge. There's a link to go to it. You can download the challenge and try it on your own, but what happened was there was a full backup, a transaction log backup, and a few more transaction log backups, and then a catastrophic failure occurred, causing the operating system running SQL Server to reboot. After the reboot, the database files were missing. And when it came back up, the database was in this recovery pending state. So here's one. I didn't plan to go through it, but I just want to throw it out as go to my website, download it, give it a try on your own. There's also a total of 7 corruption challenges you can do on your own there now. And give it a shot. So on to the summary. We went through detecting corruption. How do you find out what's corrupt? And a bunch of different ways to do it, from the suspect pages to check table to check DB to just querying, tracking the corruption, looking at what error messages you have, going through the error log, looking at suspect pages, things like that. Things to do before fixing or removing the corruption. Always make sure you're covered and you're safe. You've got a way to get back if what you attempt goes bad. And then the different ways to remove it. Sometimes you have to do repair allowed data loss. Sometimes you can truncate a table. Lots of different ways to go about that. And then for more examples, you can visit my website and try out the corruption challenge. So that wraps it up, and I'm just going to open it to any questions at this point.
Well, currently there's no questions. I actually have one.
Okay.
Instead of like manually fixing, could you just drop and rebuild the non-clustered index on the last example? Like
Yeah, that's a really good question. So instead of using the DBCC check table that ended up dropping the page and rebuilding the index, you could have just dropped the index and recreated it, absolutely. And it would have done the same thing that we saw in the way that we did it. It might have been a little bit safer. Now, the reason it would be safer is you would know that dropping and recreating it wasn't modifying anything else in the table. Now, the interesting thing on that I didn't show in that last one was, had you just gone in and done a rebuild on that non-clustered index, it would have rebuilt it without going to the base table to get all the data, and then when we ran DBC check DB after that, it would have showed the differences in those two names between the base table and the non-clustered index at that point. So if you had just rebuilt that non-clustered index, the two names that were not matching would have also shown up in the check DB. So yeah, good question.
Good. Well, thank you very much, Steve. It was great to hear about the corruption and corruption challenges, and we all enjoy doing them.
Yep, great.
And thanks for attending the HADR Virtual Chapter June meeting.
All right, thanks. Have a great day, everyone.
Thanks a lot, everybody. We will see you next month.